Now we look at another example. So this table represents the marriage status of male and the female at age 15 or older. What is the probability that a randomly selected individual, 15 years old or older, is widowed? So we look at the category of the widow. So the total sum of the population that are widow of the year has 14.3. So we use the 14.3. So finding the probability of the widow, right? It's coming from. Now finding the probability depends on the information we have. We can use the probability of the number of the widow to divide by the total sum, which means the sample space we have. So this will be the sample space, the total, right? Or another way you can get in that probability would be use the number of the widow to divide by the number of the total sample space. So this one you are using the frequency, right? Frequency number to getting the probability. And this one you are using the probability to finding the result, the outcome of the probability. These two, you will get the same number. But depends on the information you have, the data we have. This data, it gives us the frequency. So we go with this one. Okay, use a number. So this one, the number of the widow has 14.3. Divide by the number of the total sum, which means the total sample space has 251.3. So divide these two, you're getting the probability has approximately 0.057. We look at the second one. What is the probability that she is widowed? This is a conditional probability, right? It gives us the condition. She is widowed. So this is a conditional probability. They give us the notation. She is the first one, right? So she need to be there first. She is a widow. So the conditional probability of this one, I don't have space here. By using the formula, we can find in this probability has widow and a female. Divide by the probability of the second event, which is the female, she. And this is the same meaning. We use the number of the frequency, right? Widow and the female divide by the number of the female. So we look at the chart here. The number of the widow and the female. So the widow is here and the female is here. So this is overlap, right? This is end. So the person is a widow and that person is also a female. His number is 11.2. Now you divide by the total sum of the female. So you have to look at a female category. So if you go down to finding the total sum of the female, it has 128.8. So divide by these two, you will get the probability of she is widowed. So the number has about 0.087. Number 3, what is the probability that a randomly selected individual has never married, given the individual is male? Let me use another color. So never marry, given the individual is male. So this is another conditional probability. So the probability of this one, given a male, right? So never marry. They are looking for the probability of that group is never married. but the criteria must be a male. So they are looking for the male never marry. So we convert it into the formula. You use the probability of never marry, and that group is a he, is a male, and you divide by the probability of the male. And here we only have the number, so we go with the number of the never marry and male divide by the number of the male. So the total sum of the male has 122.5. Never marry of the male, so never marry and the male has 41.6. So divide by these two, you're getting the probability of the male never marry. It's 0.340. The last one, what is the probability that a randomly selected individual is male? Let me write down here. So finding the probability of is male, right? Given, put a bar, the individual has never married. This is never married. So this is the opposite direction from the number 3, right? The number 3, we found the male, right? Male never marry. But number 4, they are looking for never marry and it's male. So the criteria of number 4 is never marry first. So we convert it into, let me put a number, okay? So the number of the male and never marry divided by the number of never marry. Now look at the number of the never marry has total is 78.5. So we put a 78.5 on the denominator. The male never marry, so the male never marry has 41.6. So divide by these two, you're getting the number has 0.530. So this is the idea. You are looking for the conditional probability. Okay, and a lot of chance you will see the table like that. So the conditional probability rule, if the event E and F are any two events and they have that conditional, right? This has something overlapping. In fact, you can use this way to persuade yourself, right? It's not an independent event. So we use a vertical bar. And again, who stay in the front, that's a big differences. So you have to recognize your question. So convert this one into the probability. We are using the probability of the event F and event E divided by the probability of the event E. Or you can go with a number. This is a frequency, right? The same, like this example, we use a frequency, the number to divide with each other. But these two, they are the equivalent formula.